on every BSP release, we associate a set of tools and packages that allow you to work with the new BSP, integrated with extra features. So in the tools, the main tools component of the ecosystem are the CubeMX, CubeID, CubeProgrammer. Many of you are already familiar with the CubeMX tool. If you are already working with our microcontroller, you probably have already used the CubeMX. Now we integrate inside the CubeMX the tools, the components to work also with our APU. So thanks to this integration, you have the possibility to configure your board. In the left column of CubeMX, you will find all the device, the controllers, and the buses that are present in your MPU, so MPU1, MPU2, and you can select the bus or the device, and you can configure it in the central screen. And on the right, you can use the graphical interface to assign the functionality to the single pad and single PID or your board. In the end, what you can do at the end of the project, when you have configured all your peripheral, you can generate the project. And generate a project means that you will generate the device tree. The device tree is not the final version of the device tree, because maybe inside your device tree you wanted to add an entry for example, your EEPROM or your physical Ethernet, or some peripheral that you want to attach to the E2C or SPI bus. So you can use the CubeMX to configure your chip, so the STM32 MP2. And after you start working with the device tree, and you can use after the device tree for configure the kernel. The CubeMX is a tool that is useful also for hardware design, because when you assign a functionality to a pin, you understand what you can do with this product or your board. So you can test if the configuration that you are thinking for your custom board is works, because if there is any conflict, the CubeMX will notify you about the conflict. On the other side, we have the CubeProgrammer. The CubeProgrammer is the tool that you can use for flashing the storage of your board. So if you're using eMMC storage or SD card storage or an NAND, you can use CubeProgrammer to flash the image of your board. But not only. So the first functionality is to flash the board, but you can also program the OTP. You can reprogram the NVMe PMIC memory, so the non-volatile PMIC memory, to change the configuration of the PMIC. You can use CubeProgrammer for generating the key and spinning the image if you want to use the secure boot or the secure feature of this product. In the video here, the CubeID. Maybe you are familiar also with the CubeID. You can use CubeID to build the Cube MP2 BSP, so the firmware that can run on the Cortex M33. As you know, this product has integrated a Cortex M microcontroller. You can build the firmware for this microcontroller using CubeID. Moreover, okay, and just another point, remember that in this product, in MP2, the Cortex L can boot the system. You can create the firmware for booting the system using CubeID. You also have the possibility to build using CubeID a bare metal tool. We call these DDR firmware utils that run inside the Cortex A for testing the DDR configuration and also for testing the board. It is a bare metal firmware that runs inside the Cortex A. With the Linux version of CubeID, you have also the possibility to build the developer package. The developer package contains the low-level components of our BSP, so the the kernel, the Linux kernel, the U-boot, OP, and trusted firmware. You can build these components from CubeID in the Linux version. There is a dedicated page on our wiki that list of the components of our ecosystem, the release and the release note. So the version and the release note of CubeID, CubeMix, CubeProgrammer, but also of the other tools that are Toolbox, we'll see later, and also DDR firmware utils, programming firmware utils, SFT utils. Moreover, always associated with our VST, there are also the expansion packages. You have been already introduced to the expansion packages from Christopher. So the Xlinux AI, as already said, included the framework that you can use for running your AI model. You have also the Xlinux Qt that integrates the framework for the graphical framework Qt. Xlinux RT that allow you to use the real-time patch in our system, and many other Xlinux packages. Consider that OpenST is a Yocto-based distribution. This means that Xlinux something are meta layer that you can add on top of our OpenST Linux distribution. And after the build, you will have integrated inside your final image the new functionality. I suggest you to explore these Xlinux packages because usually it simplifies the integration of new functionality. So when you want to add some feature, or if you want to test an expansion board, look inside the list of available expansion packages, and clicking the link, you will find the link for downloading the expansion package and the description and how to use it. Let's now focus on CubeProgrammer because we are going to use it in our workshop, so it's better to give more attention to this tool. So we have a dedicated page on our wiki that explain how the release notes of the last version of CubeProgrammer and also how to use it. As I said, there is the possibility to use CubeProgrammer for OTP programming. So there is an explanation of how to use CubeProgrammer for this operation. The same for the PMIC non-volatile memory. If you want to change the PMIC configuration, you can go to this page and you find an exhaustive explanation of how to use it. And very important, the syntax of the flash layout. The flash layout is a file that describes to CubeProgrammer how to flash a board. So mainly the partition. If you want to flash a board, an MPU board, you have to partition the storage. That can be the SD card or the NC or other flash device. And in the flash layout file, you describe how the partition is being configured and how to write the image inside the partition. The CubeProgrammer is the preferred tool, the tool that we propose for flashing a APU device. But there are other alternatives. For example, the CubeProgrammer command line interface is a command line interface that uses a special syntax to run to do the same operation that you can do in the graphical interface. We also offer the STM32 programming toolbox that is an open source tool that can program the board, and you can customize this tool for adapt it to your product line, because maybe you want to speed up some process, you want to integrate some operation. You have the possibility to build on your host PC this tool and customize it to flash the board in the way that fit your need. There are dedicated pages on our wiki for all these tools. And let's now move to explore our OpenST DSP. Okay, sometimes it is a bit confusing to see that we offer 3 different packages in our DSP. It's easy. I hope that after this explanation, everything will be clear to you. The main package is the starter package. That is the image that we are using for flashing the board. Distribution package and developer package are used to customize the starter package. Let's see in what way. So, first of all, starter package, as you know, it is the package that contains the binary image. The binary image that you can use for flashing the board using the QProgrammer tool. On the opposite, we have the distribution package. The distribution package are the source code. So the distribution package contains the meta layer and the source code that you can use for building the starter package. So just a set of sources and cross compiler that you can use for build the starter package. In the middle, we have the developer package. The developer package contains the low-level components of our starter package. So the source code of the low-level components. So the source code of the kernel, the source code of the U-boot, of the opt, and the trusted firmware, and the toolchains to build them. So what you can do with this developer package is to customize the low-level components of the BSP. I hope that now it is clear. Binary, source code, part of the source code plus the toolchain. We will use all these 3 packages in our next activities. In here a summary of these components. So the starter package is associated with a board, with a single board. So we have a starter package for the STM32 MP13 discovery kit, a starter package for the MP15 evaluation board, and a different starter package for MP15 discovery kit. Since they are binary, you need these. And the same for MP25, a starter package for the evaluation board, a starter package for installing the discovery kit. The developer package, we have just 2 different developer packages, one for MP1 series and one for the MP2 series. Why? Because MP1 is a 32-bit architecture, so we need a cross compiler that is able to produce firmware for a 32-bit architecture. MP2 is a 64-bit architecture, and so the cross compiler and the toolchain are able to generate binary for a 64-bit architecture. But we have just a single distribution package. So we have a single set of source code that include the 2 compiler, okay? And from this single distribution package that cover all our APU product, you can generate a starter package for every single board. And obviously also the release notes are just one for describing the distribution package content.